Welcome back to G Fun Facts Online, your favorite pit stop for all things amazing and mind-blowing. Today, we're embarking on a journey back in time, not just to gaze at ancient wonders, but to uncover the hidden genius behind them. We're talking about those silent, towering sentinels of antiquity, the pyramids of Giza, the mysterious Stonehenge, the sprawling city of Teotihuacan, and so many more. These aren't just pretty stone piles, folks. They are profound testaments to the sophisticated mathematical understanding of ancient civilizations. And the kicker? They were doing this long before math class was even a thing. Imagine this: no fancy calculators, no supercomputers. Yet these ancient cultures were applying complex concepts of geometry, surveying, and astronomy to build structures that still leave us breathless with their precision, scale, and sheer beauty. So how did they do it? Let's dive in. First up, let's talk about the universal language of numbers and measurement. At the heart of every ancient megastructure is a solid foundation of mathematics. Think about it. How do you build something massive without a way to measure? Early civilizations were brilliant. They independently developed systems of measurement, often based on something readily available: the human body. The famous Egyptian royal cubit, for example, was based on the length of a forearm. This standardized measure was absolutely crucial for building pyramids and temples, ensuring everything was consistent and proportional. It wasn't just the Egyptians. Mesopotamian cultures used units like the kus, also a cubit, and the Indus Valley civilization had standardized weights and measures across its bustling cities. These units, though different, were the essential toolkit for turning grand visions into physical reality. They allowed for the calculation of materials, labor, and the precise layout of mind-bogglingly complex designs. Now, let's get into shapes, geometry. This was an indispensable tool for ancient builders. From the perfect square bases of pyramids to the mystical circular arrangements of stone circles, fundamental shapes were packed with both practical and symbolic meaning. Take the Great Pyramid of Giza. It's a geometric masterpiece. Its base is an almost perfect square, and its four faces are aligned with uncanny accuracy to the cardinal directions: north, south, east, west. There are even fascinating theories that suggest the builders intentionally encoded mathematical constants, like pi and the golden ratio, that magical number approximately 1.618, within its proportions. Some analyses even propose that the pyramid's height in relation to its base perimeter cleverly reflects the ratio between a circle's radius and its circumference, essentially squaring the circle. While experts still debate how much of this was conscious mathematical encoding, one thing is undeniable: the structural integrity and stunning symmetry of the pyramids relied on an advanced understanding of geometry. Then there's Stonehenge in England, another prehistoric puzzle that whispers of mathematical prowess. Its layout, especially the massive sarsen circle and those iconic trilithons, suggests a really sophisticated grasp of geometry and surveying. Can you picture it? Researchers believe its builders used clever pegged rope and compass techniques to create its precise circular and horseshoe arrangements. There's evidence that geometry was a key player in every phase of its construction, which spanned from around 3000 BC to 1600 BC. While its exact purpose is still a hot topic, its alignment with solstitial sunrises and sunsets clearly points to a deep connection between its geometry and astronomical observation. Some theories even suggest they were using Pythagorean-like triangles long before Pythagoras was even born. And get this, Alexander Thom proposed a standardized unit of measurement called the megalithic yard, hinting at a shared system of knowledge among Neolithic builders, though that's still a bit of a debate too. Fascinating, right? Jumping over to ancient Greece, the Parthenon in Athens is often brought up when we talk about the golden ratio. While some modern studies suggest its proportions might stick more closely to other simple integer ratios, like 4:9 in its ground plan and facade height to width, the Greek obsession with proportion and harmony is absolutely clear. Greek mathematicians like Pythagoras and Euclid laid the groundwork for geometry and the theory of proportions, which massively influenced architectural design, always aiming for that perfect visual balance and aesthetic appeal. The concept of asterisk symmetria, the harmonious relationship of parts to the whole, was central to how they thought about building. But it wasn't just about earthly shapes. Many ancient megastructures show an incredible awareness of the cosmos. They were aligned with significant celestial events like solstices and equinoxes. This field, known as archaeoastronomy, reveals how ancient peoples wove their understanding of the heavens into their earthly constructions, often using incredibly sophisticated surveying techniques. Consider Teotihuacan in Mexico, a vast pre-Columbian city. It was meticulously planned with a grid layout oriented to astronomical phenomena. Its main street, the Avenue of the Dead, and the placement of its massive pyramids of the sun and moon suggest a worldview deeply rooted in astronomical observation and calendrical cycles. Researchers have even identified a potential standard unit of measurement there, the Teotihuacan Measurement Unit, or TMU, about 83 centimeters, which seems to have been used to integrate cycles of the sun, moon, and planets into the city's very fabric. The whole layout screams symmetry and proportionality, pointing to a grand master plan. Then, journey with me to Cambodia and the breathtaking Angkor Wat. Built in the 12th century AD, its layout is a stunning reflection of Hindu cosmology, representing Mount Meru, the mythical home of the gods. The temple's dimensions and alignments correspond to solar and lunar cycles, basically turning it into a vast astronomical observatory. Measurements within the temple have been shown to record calendrical and cosmological time cycles, often based on the Cambodian cubit, called the time hat. The intricate sacred geometry of Angkor Wat, including its mandala-based layout, was all about creating a cosmic map connecting the earthly realm with the heavens. Mind-blowing stuff. And what about the Great Wall of China? While primarily a defensive structure, just imagine the immense logistical and surveying skills needed to build it across such vast and varied terrain. Ancient Chinese surveyors used tools like the gnomon, a vertical stick to determine direction by its shadow, compasses, and measuring rods. Mathematical texts, like the Haidao Suan Jing or Sea Island Mathematical Manual, even provided methods for solving complex surveying problems, showing a sophisticated understanding of geometry, including right-angled triangles. The sheer ability to plan and execute construction over such enormous distances showcases truly remarkable mathematical and organizational skills. Let's not forget Roman engineering. Structures like the iconic Colosseum and their extensive aqueduct systems relied heavily on practical mathematics. The Romans mastered the arch, which allowed them to build massive, durable structures that still stand today. Their engineers were skilled surveyors, capable of calculating precise gradients for aqueducts to ensure water flowed consistently over many, many miles. They also standardized units of measurement, like the Roman foot or asterisk piece, which even influenced later European systems. While they might have been less focused on abstract mathematical theory in their constructions compared to the Greeks, the Romans absolutely excelled in applied mathematics for engineering and building incredible infrastructure. Beyond all the abstract calculations and geometric designs, there's the human element. Constructing these megastructures required an extraordinary level of planning and organization of labor and resources. And guess what? This too is a form of applied mathematics. Estimating materials, managing workforces that often numbered in the tens of thousands, and ensuring a steady supply chain over extended periods and vast distances. These were monumental undertakings that relied heavily on numerical calculation and logistical brilliance. So while research continually uncovers more about the mathematical knowledge of these ancient civilizations, many questions still linger. What were their precise methods of calculation? How deep did their theoretical understanding go? How was this knowledge passed down? Were sophisticated concepts like pi and the golden ratio deliberately encoded? Or are some instances just happy coincidences that arise from practical geometric constructions? The debates continue, and that's part of the fun. But what is absolutely undeniable is the ingenuity and intellectual depth of these ancient builders. They weren't just piling stones, folks. They were keen observers of their world, abstracting principles from it, and applying sophisticated mathematical reasoning to shape their environment in ways that were both functional and profoundly meaningful. The mathematics embedded in these ancient megastructures speaks to us across millennia, a silent but incredibly eloquent tribute to the enduring human capacity for understanding and mastering the patterns of the universe. Their legacy isn't just in the stone and earth they shaped, but in the powerful demonstration that mathematics has always been, and continues to be, a fundamental tool for human civilization and its grandest ambitions. Isn't that incredible to think about? Next time you see a picture of a pyramid or Stonehenge, remember the hidden numbers, the secret geometry, and the brilliant minds that made it all possible. That's all for today on G Fun Facts Online. Join us next time for more amazing discoveries. Stay curious.